the chat session. Yeah, so at the end of this session, we'll be able to explain common regression models and identify appropriate use cases. We'll focus on linear regression. We'll learn about the evaluation metrics. We stated them in the previous class. We said, like, when you want to see if a model is actually performing well, there are ways that you can evaluate that model to see if it's performing well. And we also talked about making it perform well by maybe tuning hyperparameters and such things. So we are going to learn more about mean squared error, root mean squared error, R squared error. We are going to build a linear regression model using scikit-learn. So if you can remember, I gave a high-level explanation of these Python libraries. So scikit-learn is like the library for machine learning. So most of the algorithms for machine learning, the ones that we have already learned, except neural networks, we are going to use scikit-learn. But as I said, it's not something that should scare you, because it's more like from scikit-learn, import linear regression. From scikit-learn, import polynomial. It's like they already exist, so we need to learn how to use them. Also, if you want to know how they exist, it's okay. You can still go and dig deeper, see how they came to exist. Because as I said, Python is open source because we have a big community contributing to all these libraries. So you can even contribute. You can even contribute to scikit-learn. You can go and see how it's created. You can identify some weaknesses and so on. So you can also, do your research, but also if you know how to use it, still okay. And then apply concepts through a practical exercise and a portfolio level assignment. But I think our project will help us to apply the concepts well. So we talked about regression. Common regression models include linear regression, which we said it predicts continuous outcomes by modeling the relationship between variables. For example, we talked about features and labels. We said I'll always use the housing example because I feel it's a wide example to use because a house has a lot of properties. So we have features and we have our label, which is the price. So we want to see if I want to purchase a house for this price, with these features, how much will be the price in this specific neighborhood, and so on. So we said it predicts continuous outcomes. That's a number. Price is a number. Age is a number. So you see, we had a question on categorical and numerical. So categorical data is the one that has like categories. For example, gender. We have male and female. The answer for that was gender. And guys, you guys failed a lot. So gender, male, female, that's categorical. So numerical is just a number. So most of our linear regression model predicts a continuous output. We also talked about logistic regression, but it's like, this is for classification, but it's still a regression model. It uses the regression mechanism to output classes. And we talked about logistic regression being a binary classifier. But we said if you want to make a binary classifier, binary that is 2 classes, if you want it to predict more classes, there's a function that's called softmax function that will enables us to predict more classes. And I said that's used mostly for if you have a lot of classes. When you apply that softmax function at the end of your prediction, it's going to categorize into all those classes. Then we also talked about polynomial. When I said it's like an advancement of linear regression, we talked about ridge and lasso, where we said they are like regularization methods. We don't want our model to overfit. So we're trying to create a model that does not overfit, a model that does not underfit, and a model that is robust. So ridge and lasso come handy. I know we didn't talk about elastic net, but really elastic net is like a combination of, I think I should use like a pen. Yeah, so elastic net is like a combination of ridge and lasso. So it's like it picks the good properties of each. So I said between lasso, I think it's lasso, yeah, L1. It does feature selection. So it is going to reduce some features into nothing. It's going to remove some features. And read is going to compress the features. But now ElasticNet picks the good traits in both. So it's like a combination of read and lasso. So once you understand read and lasso, ElasticNet is just, an advancement of them. Then we talked about support vector regression, where we said a support vector machine is going to create it's like a boundary, a big boundary between these classes. So it's going to create as big boundary as possible. But we also said that it has property that's called kernel trick that enables it to separate even in most complicated situation, even the closest of four classes. Yeah. So, and also don't forget, if still you feel like this content feels new to you, once you repeat it, it's going to feel easier. Yeah. So, okay, before I proceed, any question? Or are we together?
Yes.
Okay. So still on linear regression, it's a supervised machine learning algorithm. So if you can remember, we talked about supervised and supervised. So you need to give it a labeled data. You need to tell it, you need to train it with labeled data. Tell it, this is it, this is this is this. If a house has these features, this is the price. If a house has this many bathrooms, this is the price. So that it learns from the data, so that it's able to predict from new data. So it is used for predictive modeling, where relationship between the dependent variable, that is the target or the label, and the independent variable, which is the features, is modeled using a linear function. That's why it's a linear regression. Also, another thing I want you all to understand about algorithms, the origin of algorithm is from mathematics. Like most of these mathematicians have researched ways in which they can manipulate math into doing those data tasks. We have statistics as a field which deals with data. Then now they're able to put it in a way that a computer can use that model. So most of these models are like from mathematics. So you just realize that it's a linear function. Like this is, as I said, it's like a straight line, the baseline of it. So yeah. And you've said it predicts a numeric value that is used for continuous target variables, like a number. So before I even go to like the simple linear regression or the multiple linear regression, it's important to realize like some of the application of like a regression or maybe linear regression model in real life would be predicting the stock values, predicting the for those people who do forex trading and everything. You can use such a model to predict the what is the market, what will the market look like based on the yesterday's data and last week's data and so on. You can use it to predict. Another example is the one that I've used for a real estate. You can it has a lot of anywhere that you need to predict a value. If you're in a marketing field and you want to see how many sales you guys are going to make the next month based on these advertisements. Talking of that, that's the project that we're going to do, advertisements. So you have different marketing channels. So you're marketing using television, you've used billboards. Each company has its own marketing budget. So based on the past data, you're able to predict based on the past data, based on the current situation, you're able to predict how much sales that you're going to make, and so on. So it's used for those data-driven decision making. So we have a simple linear regression where it just has one feature and one target. So it's just like the area of the house and the price. So the area directly determines the price of the house. But now real life data does not really have one feature. As I said, in a house setup, we have a lot of factors, a lot of features that make a house. And we have different clients who want different things. Some want a balcony, others want back door, others. We have a lot of features. So it's we have now the multiple linear regression. So a linear regression algorithm is able to take as many features as possible and also still be able to predict something like a house price. So any question? Are we together?
Yes.
Okay, so this is just visual view of linear regression. As I said, it's the baseline of it. I think we have okay. Okay, I didn't write the explanation, but basically this is it. An equation of a straight line. We have a lot of data points, and we know that normal equation, the one that we learned in mathematics, it's y is equals to mx plus c. Okay, that's the one I know. Some use b plus c. And we know that m is the slope, x is, I think, the change in this x-axis, and c is the intercept, the y-intercept. And also, we have learned when we were doing like geometry and such things, we have learned a lot about baseline of it, especially when you are dealing with graphs. You want to pick the baseline of it. So that's like the logic behind linear regression, basically. Yeah, this is just like a visual presentation of, a straight line and intercept uh, the it in a xy axis. So basically just a visual presentation. So we have several assumptions when it comes to linear regression. Like, because they're algorithms, they work the way when you develop a theory or when you come up with something, there has to be some assumptions you're making in order to for it to work. It's not like ideal. So we have several assumptions. So the first one will be linearity between independent and dependent variables. So one thing about independent variable, this is the features. Dependent, this is the label. This is what we're predicting. So just in case I use independent and dependent, that means features and label. So linear regression assumes a relationship between the features and the label. So it has the linearity component. So I've explained here when you use a scatter plot. I'm losing my pen. Let me just choose a brighter color, maybe color green. Yeah. So when you use a scatter plot, and maybe if your data is like linearly distributed, it's easy to see how that linear regression is working, because it's assuming linearity between x and y, because as I said, it's an equation of a straight line. So y is connected to x. So yeah, it's an assumption. We have another assumption that's called multi-collinearity among independent variable. So independent variable should not be highly correlated with each other. What is multi-collinearity? So it's like linear regression assumes that the features. Okay, this writing is boring. Let's say x to represent the features. They are independent of each other. They're not connected. And if you have features that are highly correlated, you can even confuse the model. So let's say I have the area of the house in square meters, and I have another feature that captures the area of the house in feet. Those are that's like the same thing. So that's why regularization comes in place. That's like redundancy. It's giving the area. So it assumes that the features are independent of each other, but they are actually related to the label. I don't know if we are clear on that. Any question? Any comments? Are we together?
Kindly repeat the last part.
The multicollinearity part.
Yes, please.
So, linear regression assume that features are independent of each other. Like, it will assume that the area of the house is not related to the bathroom, it's not related to the color of the tiles, not related to the size, number of bedrooms. So it will assume that the features are independent. Is that clear? Is that like simply explained?
Yes, thank you.
Okay. Um, Normal distribution area error. How do you explain this one? So because we are dealing with normal data, I won't say normal data, but for a linear regression, the error should be normally distribution. So a normal distribution curve looks like this. I'm looking for a better example. The way we used to say, like, even in a class setup, results are usually normally distributed. I don't even think that curve shows that very well. It's usually called the bell curve. So majority of students lie here. This is like the average, Then we have, let's say, the top, let's say the bottom, depending on what we're checking. So this is a normal distribution curve. So the errors for a linear regression are like normally distributed. So I don't have an exact example to explain this, but I look for like a mini project that can show this. I think that will work better. That will work better because there's no way I'll explain the errors. You have to do it, then you analyze the error side. But if I get a simpler way to explain it, I will. Yeah, but that's an assumption of linear regression, and then there's the independence of errors. The errors should not be related with each other, should not be correlated with each other. So that's also an assumption of linear regression. So I don't know if you're together in this. So any okay, before I move to the next one, any question on the error part? Okay, so the other assumption is this one, homoscedasticity, constant variance of errors. So the residuals or error should have a constant variance across all levels of predicted values. So what's variance to start with? Mathematically, what's variance? Hello guys, this is simple. What's variance so that we understand what a constant variance means? Come on guys, you guys don't know what variance is in relation to
The difference.
the difference between.
The difference across all levels.
So like simply explained, like the normal variance is usually like how far apart a value is from the mean value or from the average. So that's like the variance. So when you want to get a variance, we usually take um I think that value minus the mean, or mean minus the value, the difference between that value from the mean. So let's say we are doing ages, then the mean is 15. Then you have a value of 17. So 17 minus 15, that too is the variance. So if I can jog your memory a little bit, we have variance, then we have standard deviation, etc. So the error should have a constant variance across all levels in the predicted values. How do I explain this? Like no matter the value of your features, your errors will have a constant variance. Um yeah, I think this one is also more practical than it is theoretical. Yeah, so I think we'll have to visualize a lot in that mini project. Anyways, so evaluation metrics, mean squared error. So we have error, then we square the error. What do I mean? We have the error, then we square the error. So let's say this is my regression line. I'll just use the simplest. Like, we have two features. So these are some of the data points I'm trying to plot. I hope you can see. So let's say this is my model, what it has predicted. Then this is like the actual values that it should have predicted, the red one. Now the dots are too small. So for a model, the error is the difference between the predicted value and the actual value. It's supposed to be the error. So what mean squared error does, it squares that error. So you get the error, then you square it. Which means if the error is large, then you square the error, it's going to give even a bigger error. So it means you should like not have like big errors. It's like you're trying to make if you're trying to make a model have a small mean squared error, it means like you're trying to make it have as less errors as possible. The errors won't be so big, because if the difference is big, it means the error is big. So our mean squared error is basically like the average of all those errors when they are squared. And the root mean squared error. Now you see, we have taken the error, let's say the difference between the actual value from this house and the predicted value, let's say it's like 20 $20. So when you square this error, it's going to give you, I think it's 400. This will be our error. Like, so it's like a metric, because the bigger the error, the bigger the model is. Okay, the more wrong the model is, the bigger the mean squared error, which means the more you try to minimize the mean squared error, the more accurate your model is. And now, because this is squared value, that's why we have root mean squared error. Root mean squared error, on the other hand, is like the square root of this, because we have already squared the error. Now we need it in our value. So you see 400 is already like $20 squared. But now root mean squared it's in the units of the target variable. So it's like this is the mean squared error, this is root mean squared error. So they are related. Then we have, I think I forgot to add, we have the mean absolute error, because we already know what absolute mean. Absolute is the difference between the actual and the predicted without the negative part, like the absolute value. So mean absolute error is like the average of all the absolute errors. So the smaller it is, the more accurate your model is. Then we have the R squared error. Some call it R score. So if you still find it R score is still the same, R squared, etc. So It's the proportion of variance in the dependent variable. Okay, this is going to be explained better. So it's like R squared tries to see how much of the data the model has captured or the model is predicting from. So if you get the higher, it usually ranges from 0 to 1. But if you get R squared that's negative, like your model is way out there, your model is bad. It's bad. If it's negative, like it's just so bad. So it's 0 to 1. So the closer that value is to 1, the more your model is, because it means like if my R squared is 1, it means like my model is predicting from all the data. So it's been able to learn from all the data. So if it's 0, it means like it's just, I don't know. I don't even know what it's predicting. But yeah, so if you're measuring using the R squared error, you're going to see if that error is closer to 1. Of course, in ideal cases, you won't get like 1, but at least 0.9, 0.92, something closer to 1. That's a good model. So this is just a range of how, oh, 0.9 to 1 is like an excellent model. Sometimes you won't get that value, so don't worry. If it's at least here, still it's okay. Yeah, so these are like evaluation metrics. So the more you actually model with, you create models, the more you're going to understand this matrix, or the more you are going to see the models like perform in real world. So I have like several suggestions. I wanted you guys to check Kaggle. I'll send the link in the group. Kaggle is like a platform for data scientists. So you'll find like a lot of data sets, you'll find a lot of projects going on, a lot of hackathons. It also has some resources. So you can even pick even the most, you even find like some projects that are already done, but people have like the code repositories like in public. So you can go and check like a simple linear regression model, see how somebody has done it, how they have concluded, etc. You can even create your own models. You can even enroll in some hackathons. It's going to build your skills in building models, because one challenge about being an AI engineer is like data. You need data. So Kaggle as a site provides like a lot of data sets which you can practice with. We also have another one, Zindi Africa. Zindi Africa is also like a good platform for doing hackathons. So if you feel like you're up for a challenge, you can just go and check. There's usually like a lot of hackathons, a lot of competitions going on. So you can just go and check. You can even check the projects that have already been done. But I don't know if Zindi usually gives like the code repositories. But at least Kaggle is going to help you. You're going to learn from people who have been trying to practice, trying to crack these things, and they have managed. Yeah, so I'm going to send the links, because the more you do practically, the better you understand what all this means. The more you do, maybe you evaluate a model with root mean squared error, then you try to reduce the error. You're going to get a better understanding of what you're doing than just explaining the concept. Yeah, so we have a small mini practical project on linear regression. At least I've managed to be as fast as possible. So you're going to explore the data set, you build the model, then you test the model. This is just, I'm supposed to exit the presentation mode. That's bad. Okay, so I'm going to group us into, I want us to have like a group assignment. It will help us network well, and also you can learn from your peers. So if you're actively present in class, just type your name in the chat so that I can group you guys. Oh, before I do the grouping, sorry guys, any question? Any concern or any comment? I can still like check a comment. Any comment? Like, are we together up to there?
I have a suggestion or
Okay.
question.
Okay.
Um, with the assignment on the model that we're going to explore and test,
Mm-hmm.
are we going to get like a quick overview or a quick walkthrough of what we are doing?
Okay, I can do that, but also I would like for you guys to just try to brainstorm a solution, then we can come up with a solution as a class. Like if I show you the whole code, then you won't get the opportunity to try to learn from your peers.
Okay,
Yeah, so like that's why I didn't want you guys to do it like individually, because like I know individually it can be kind of hard, but then when you do it as a group, you're going to brainstorm, you're going to have like suggestions, then you can come up with something. And also you're not limited, you can chat GPT as long as you understand what you're doing. Don't over rely on chat GPT, but then it's an AI, so it's going to help you. So yeah, so it's an opportunity for us to see what we can come up with. Then we can still review the code. I have the project, but I'm going to send it later.
okay,
So from the participation, we had like 14 participants in the quiz, in the Menti quiz. But I'm only seeing one, two, three, four, five, six students. So that's all we have in class. And I can see we have, apart from those AI assistants, at least I know we are like around 14. But I can still work with that. So this will form two groups. Mm, Faith Chepngeno, Sharon Keta, Lavenda, I think that's one group. Then we have Karen Nyawira, Linda Riziki, and Imani. That's another group. Then Audrey will go to the first group. Marianne will remain in the second group. So the group is like this: Faith Chepngeno, Sharon Keta, Lavenda Doris, and Audrey, group one. Then Karen, Linda, Imani, and Mary Ann, group two. So you guys can still like, I don't know. I'm suggesting you get you can create like your a small link, you have a discussion, a small Google Meet link, you have a discussion. Use Google Collab because it's the easiest to use, and also, you know, yes, Mary.
I don't have a group.
Mary, you have not typed your name on the chat. Okay, let me regroup again. So I think we'll have 3 groups. Yeah. So that each group will have like 4 people. That is more reasonable. So the first group will be just this. The first group, as I had said, Faith, Sharon, Lavender, and Audrey. The second group is Karen, Linda, Imani. Okay, so group 3. Group 3, we have Tamia, Esther Maina, Pauline, and now Mary. Mary, you're falling in that category. So Marianne, you're in group 2. So let me just repeat the groups. Group 1 will have Faith Chepngeno, Sharon Keta, Lavender Doris, and Audrey Pendo. Group 2, we have Karen Nyawira, Linda Riziki, Imani Vata, and Marianne Tukiko. And group 3 will have Tamia, Esther Maina, Pauline. Tamia, Esther Maina, Pauline, and Mary. Is that okay? Yes, Atina, I've not placed you anywhere.
Yeah.
Oh my god. I'll just throw you to group 1. So your group members are Faith, Sharon, Lavender, Audrey, and you now, Atina. Nicole, you're going to fall in group 2. So if there's anybody who has not like stated their name, you're automatically going to fall in group 3. So just to repeat the groups. Group 1 is Faith, Chepngeno, Sharon, Lavender, Audrey, and Atina. Group 2, we have Karen, Linda, Imani, Marianne, and Nicole. Group 3, we have Tamia, Esther Maina, Paulina Thiambo, and Mary. Yeah, so if you don't have a group, you automatically group 4. So the thing is, I'm going to give you a small assignment. Let me just upload something on the chat. I don't know. I don't know if I'm able to upload anything, so I'll just send it via WhatsApp. I send you a data set, a small data set. It's called advertising. We talked about like marketing. Yeah, so it's just a simple CSV file, honestly. So I also dropped the assignment, what is expected of you. Just a minute. So a small assignment. I've posted it in the group. Just the instructions, but basically, at least this will help you. Like it's like a guide. So like explore, prepare the data, build a simple model, evaluate using the matrix, etc. So you can go as wild as you want. I'm not like limiting anybody. Yeah. So I think the first thing would be like to link up with your group members. I think WhatsApp group is good. but also via the chats. Then once everybody has communicated, you can just start the assignment. If you have any question, this call is on, so you can just ask anything or text me via WhatsApp. Any question?
Could you please share the list?
Okay, okay. I think that's cool.
Okay.
So I share it via WhatsApp. That's okay.
And when is the assignment due?
Oh yeah, you guys, I want you to use the next 30 minutes to do the discussion. At least by the end of the 30 minutes, I should have something. You guys should come up with something because I want it like it's part of today's class, so that I want us to see what we've come up with. Is that okay?
Okay, could you create breakout rooms instead? Because I don't know if you'll be able to reach everyone in the group. Like
Okay, so
create a like WhatsApp.
okay. Martha. Hello, Martha. Are you in the call? So can you kindly create like a breakout rooms for the groups because I think you're the host. So that's group one. So for the person who suggested that we create a breakout room, I think I might need your assistance in creating one. Like, how do we create a breakout room?
Okay, the host can go to like there's an activities icon at the edge of the okay like the dots. There's many dots at the corner, and then at the activities section, there's an option to do breakout rooms for the host only. So
Oh, so the host is the only person who can create the breakout room.
yeah,
Okay.
if it's not there, they can do like an there's a plus sign that's normally there. Then they can do like an add-on feature. Then it will suggest like breakout room.
Okay. Okay.
Yeah,
Let's try
yeah.
that.
Okay.
Thank you.
Okay. Then she can also like assign the people, or she can just create the groups. Like if there are four, then since we know our groups, we can just join.
Oh, it's like you can already like distribute each member to their respective groups.
Yes.
Okay. That's
Or she can let Google Meet shuffle us like if there's no time.
okay.
Yeah.
Let's see if that's like possible given the time that we have remaining. Okay, so the option is not there on our end. I don't know if it just works. I don't know. Does it like work for the paid Google or just any Google Meet?
I've shared a link. Like
Oh
maybe
yeah.
we can just do this by ourselves. Then for the next one, you can just set it up like before. Wait, before you send like the invite, usually send.
Oh, like okay, like set it before the class, like
Yeah, so that it's when you want to put us in breakout rooms, you can just these are you can just click it and then we'll get the prompts to join the breakout rooms.
that's actually a great idea. I didn't think of it initially. So I'll
Okay.
put it into consideration in the like the next classes to come. But for today's class, I don't know how we are going to approach the today's exercise. So I need suggestions from you guys now.
We work on it and then present on Thursday.
Okay, okay. And now because you're going to present on Thursday, I'll expect better results. Is that okay? So I've sent the groups, the group divisions in your group in the group. So please find each other, and it's also a great opportunity to get to know your peers. Yeah. And Nicole, thank you so much for the video. I'm going to go through it at least, and I think it's going to help in the upcoming classes because I also want to us to do like a lot of collaboration.